Hey everyone, and welcome. Today, we are going to crack the code on one of the most feared problems on any quant test. Yeah, I'm talking about work rate problems. If you've ever felt that little pit in your stomach when you see one of those questions pop up, well, you are in exactly the right place. I mean, seriously, does a question about Paul painting a fence twice as fast as Jane, or, three different pipes filling up a tank, does that make your brain just kind of short circuit? Yeah, you are so not alone. It almost feels like these problems were designed just to trip us up. And hey, that is not just me saying that. Check this out. This quote is straight from a GMAT Club forum, a place filled with people who are deep in the trenches of test prep. They say these problems can be a tad bit nasty and messed up at times. So yeah, it's a shared struggle for sure. But here's the good news, and it's really good news. There is a much better, much more intuitive way to solve these things. Okay, so here's our game plan. First, we'll quickly look at the problem itself and the old school way of solving it. Then, we're going to introduce a much better way, the LCM method. We'll see it in action, talk about how it helps you dodge common traps, and by the end of this, you're going to have a new quant superpower. Let's do it. All right, so first things first, what is the work rate problem? Well, it's usually got a few people, or maybe some machines, all working away at different speeds. The question is almost always, how long will it take them to finish a job together? Or maybe what part of the work did one person do? And man, it gets really messy when they start and stop at different times.
Okay, so let's talk about the textbook approach. The standard way we're all taught to do this. It's all about thinking of the entire job as just one single thing. And then you have to figure out everyone's rate as a fraction, like 1/5 of the job per hour. And sure, it works, but oh my gosh, it can get messy with all those fractions and fast.
And this slide just lays it all out perfectly. Look at the left. That's the old fraction method. You're trying to add 1/5 and 1/15. I mean, you can do it, but it is so easy to fumble the calculation under pressure. Now, look at the right. This is our new approach. Instead of dealing with fractions of one job, we're thinking in whole units of work. And suddenly, the math is just 3 plus 1, that's it. You get the exact same answer, but the road to get there is just so much cleaner. It's a no-brainer. All right, so let's officially introduce this game changer. It's called the LCM method. And the best part? This isn't some crazy new formula you have to memorize. No, it's just a simple but really powerful shift in how you think about the problem from the very beginning.
So here's the secret sauce. The whole idea is that instead of calling the job 1, we just make up a better number. We pick a convenient number of units for the total work. And what's the most convenient number? Well, it's the least common multiple, the LCM, of all the times given in the problem. And why do we do that? It's simple. It absolutely guarantees that every single work rate you calculate will be a nice, clean, whole number. No more fractions.
Okay, enough's theory, right? The only way to really see how awesome this is to actually use it. So let's dive into a couple of real GMAT-style problems and watch how this method just chews them up. So here's our first example. We've got Paul, who can finish a job in 3 hours, Abdul takes 4 hours, and Adam takes 5. The question wants to know what fraction of the work Adam does if they all work together. Now, the old way? You'd be adding 1/3 plus 1/4 plus 1/5. Let's see how the LCM method handles it. Okay, let's walk through this. Step 1. What's the LCM of the times? 3, 4, and 5. That's 60. So we're going to say the total work is 60 units. Easy. Step 2. Find their individual rates. Paul does 60 units in 3 hours, so that's 20 units per hour. Abdul does 60 in 4, so that's 15 units per hour. And Adam does 60 in 5, which is 12 units per hour. See? All whole numbers. Now, what's their combined rate? We just add them up. 20 plus 15 plus 12 is 47 units per hour. And the question was, what's Adam's share? Well, he contributes 12 units out of that combined 47. So the answer is just 12 over 47. Done. Look at that, not a single messy fraction calculation in sight. All right, you ready for a classic twist? The pipes and cisterns problem. This is where things get interesting, because one of our workers, pipe Z, is actually working against the others. It's emptying the tank. This is where people get totally tripped up with the old fraction method. But just watch how easily the LCM method deals with this. The LCM of 20, 30, and 45, that's 180. So let's say our tank holds 180 units of water. Now, pipe X fills at a rate of 180 divided by 20, which is positive 9 units per minute. Pipe Y fills at 180 divided by 30, so that's plus 6 units. And pipe Z It empties the tank in 45 minutes. So its rate is 180 divided by 45, which is negative 4 units per minute. We just make it negative. So the net rate is simple, 9 plus 6 minus 4. That's 11 units being filled every minute. To find the total time, it's just our total work, 180, divided by our net rate, 11. Boom, 180 over 11 minutes. It just makes so much sense.
And this leads me to maybe the most important point of all. This method isn't just about being faster, it's about being safer. It's like it has built-in guardrails to help you avoid those simple, silly mistakes that always seem to happen when you're under pressure. I mean, think about all the classic blunders. People accidentally add the times together instead of the rates. They totally mess up the signs on those emptying pipes, just like we talked about. And of course, the big one, simple calculation errors with fractions. The LCM method pretty much saves you from all of these because you're staying in the safe, happy world of whole numbers. This table here shows it crystal clear. On top, with the fraction method, you have to do 1/6 minus 1/8. You have to consciously remember to subtract. It's an extra mental load. But look at the bottom. With the LCM method, our total work is 24 units. The filling pipe has a rate of +4. The emptying pipe has a rate of -3. The sign is right there, attached to the number. It's not something you have to remember to do. It's just part of the rate. It makes it so much harder to mess up.
Okay, so let's bring it all home. What we've really done today is learn a whole new mental model for these kinds of problems. And honestly, this is your new superpower for the quant section.
Seriously, if you only remember one thing from all of this, make it this sentence. Stop thinking in fractions. Start thinking in units. The second you see a work rate problem, just make that mental switch. Forget about one job. Think about a big, easy-to-divide pool of work units.
Now, I gotta be honest with you, there is one small catch. This method is an absolute beast for any problem with defined numbers, 3 hours, 20 minutes, whatever. But if you get a weird problem with variables in the time, something like x takes t hours more than y, then you might have to go back to the old algebraic way. But trust me, for the huge majority of problems you're actually going to see on a test, the LCM method is your ticket. And that just leaves us with one final thought to chew on. Think about it. We didn't change the problem at all. All we did was change the unit we used to measure the work. And that simple shift transformed a nasty and messed up problem into something, well, into simple addition and subtraction. So the big question I want to leave you with is this. What other complex problems, maybe in math, maybe somewhere else entirely, could suddenly become simple if we just found a smarter unit of measurement?